Good day, everyone. You're welcome to Born Tutor channel. Today, we'll be talking about theorems of plane shapes. And when we're talking about theorems of plane shapes, I would like us to start from the lowest form of it. So, we're going to start with parallel lines. When we're talking about parallel lines, you're talking about two or more lines that moves in the same direction and have the same distance between them all through. And these two or more lines that we're talking about here can never meet each other. So we can say these lines like this are parallel to each other. Also, we can say these lines are parallel to each other. But you cannot say these are parallel lines. Why? Because the two lines meet at a point. And these two lines you are seeing here, they are not with the same distance between them throughout. They do not have the same distance between them all through. So we cannot call this line parallel line. And also you cannot call this line a parallel line because you will notice that at some point, if you extend these two lines forward, they will actually meet at a point. But parallel lines can never meet at any point. They will keep the same distance all through. So those two lines are called parallel lines. And after we talk about parallel lines, now we move to what we call a transversal. A transversal is a line that cuts through a parallel line. Let's say you have these two parallel lines like this. Any lines that cut these two lines like this is called a transversal. So let's say this is line A, B, this is line C, D, this is line E, F. Let me magnify the image for you to be able to see clearly. You have these two lines like this, and you have a transversal. This is AB, this is CD, this is EF. This line AB and line CD, that is, the line AB is parallel to line CD. Line AB is parallel to line CD, and recall this line EF is a transversal. It's called a transversal. And from this, we are going to bring out some theorems of angles. So stay on the channel and keep watching. Find a comfortable place to sit down. And if you're coming across my video for the first time, please don't forget to subscribe to this channel and on your notification bell, because on this channel we'll be talking about problems in mathematics and we'll be finding solutions to the problem. So let's keep watching. This is a big picture of what I was explaining earlier. We said line AB is parallel to line CD, and since they are parallel, they are moving in the same direction, and it means they can never meet. And if you see this diagram carefully, you will notice that the two lines keep the same distance all through and they can never meet. And we also have our line EF as this transversal of the two parallel line, that is the line that cuts the two parallel line at a point. So now you will notice something, that this line that, or this transversal, makes an angle with this here, and let's say we call the angle here A. It also makes an angle with this one here. Let's say we call it, sorry, let's call this one A. Let's call this one B. It makes an angle here also. Let's call it C. It makes an angle here also. Let's call it D. And if you come to the second parallel line also, it also makes some angles with it also. We stop at D here. Let's call this one our E. Let's call this one F. Let's call this one G. And let's call this one H. So what I'm trying to tell you here is that you will notice that the transversal makes some certain angles with the two parallel lines, and that is where our theorems are going to be coming in. So the first one I want you to understand here is that, let's take our A for a start. The line, the angle that we have here, which is A, and the angle that we have here, which is B. And if you remember, angle on a straight line is what? Yes, 180. Angle on a straight line is 180, which means whatever your A is, it will be 180 minus B. That is, your A plus B will be equals to 180, which means anything you have here, if you subtract it from 180, you have the other angles you have here, which is A plus B equals to 180. And also the same thing applicable to this one also. Your D plus C, your D plus C also is 180. Your D plus C also is 180. So there's another thing we call a corresponding angle. If you notice one thing, the kind of shape you have here when the transversal makes some certain angle with the parallel line here is also equal to this one here also. And that means your D sorry that means your B that you have here looks exactly like your F. That is, your B is equals to your F, and these two angles we have here is what we call corresponding angle. And that is not the only corresponding angle we are having here. You can notice that if your B is equals to your F, that means your A is equals to your E, also in the same position and also looks alike, which means your D is also equals to your H, and your C is also equals to your G. And all these angles you have here are what we call corresponding angles. Corresponding angles are what we call corresponding angles. Also, there is also another angles that is called an alternate angle. Now, there's also an angle that is called an alternate angle. And when we're talking about alternate angle, I'll just give you the smallest principle you can use for it. If you have two parallel lines and you have a transversal, just try and draw a Z. If you draw a Z, you will notice that if you extend this line forward and you extend this line forward, you extend this one up and you extend this one down, you will also come across this shape. You will come across this shape. And what are alternate angle? The angle with the upper side of the Z here and the angle with the lower side of the Z here are what we call alternate angle. And it means the angle you have here is also equals to the angle you have here. Now let's come to the real diagram. You will notice that this line here that stops here, extend here, and also comes back here, gives you a Z shape, which means the angle D that you have here is equals to what? Your angle F. Is equals to your angle F. Your D here is equals to your F. Also, you will notice that this, since here is equals to here, and we said angle on a straight line is equals to 180. Don't forget that your D plus C is equals to 180, and your E plus F also is equals to 180, which means if your D is equals to your F, whatever the value you have for your C will also be equals to your E, and also it's also an alternate angle, because you have something like this, which is also like a very wide Z. It will be in this form, and the angle you have here will be equals to the angle you have here also. It is called, these two are called alternate, they are called alternate angles. They are called alternate angles. That's the second one. There is another one we call vertically opposite angle. We said vertically opposite angles are equal. What do we mean by that? Vertically opposite angle is telling you that your your B and your D are equal. That is, your B is equals to your D, because they are oppositing, they opposite each other vertically. So your B is equals to your D. Also, your A is vertically opposite to your C. That means your A is equals to your C also. And if you come down here also, your E is equals to your G, that is vertically opposite angle, and your F is equals to your H. Also, it is called vertically opposite angles. Vertically opposite angles. they are equal to each other. And I think that's the third theorem we are talking about here today. And the last but not the least theorem I'll be talking about is what we call co-interior angles. Co-interior angles means two angles that opposite each other in an interior in the interior of a shape. Let's take this for example. You can notice that these two lines have some angles within them. And if you notice, your C and F here, they are interior angle for a shape that is like this. You have the shape like this, and you have your C here, and you have your F here. So we can actually say your C and your F here are co-interior angles. And by that, co-interior angles are not the same. Unlike the vertically opposite angle, the corresponding angle, or the alternate angle. But co-interior angles are supplementary angles. And when we're talking about supplementary angles, we are talking about two angles being added together to give you 180. Which means if you add your C and your F together, your answer should be 180. The same thing applicable to this the same thing applicable to this other side also. If you add your D plus your E, it's also supplementary angle. That is, your D plus E also is equals to 180. So let me give you the summary of what we have been talking about today. I'll give you the summary of the four types of theorems we talked about today, and we do some examples and see how you can apply them into real mathematical problem. So stay on the channel. So let's see this example first. This is an example on what we've been talking about before, and let's see how you can apply it in real life. If you look at this shape now, you can see that this line is parallel to this line. This line is parallel to this line. And what can you see in that? How do you solve this problem here? Sorry, don't mind my shape. I used hand to just draw it, so don't mind how it looks. You can notice that even this line is being extended upward and downward. It will be a transversal for these two opposite these two parallel lines, and the same thing applicable to this one also. If it is being extended upward, it is also a transversal for the two lines. So let's extend those lines, maybe how they should be. Let's extend them and see how it goes. Okay, so what you notice now is this is a straight line. Please don't mind my drawing. This is a straight line. It should be a straight line because the shape will end up looking something like this. The shape will end up looking something like this if everything is being extended, whereby here is your x, here is your 42 degree, and here is your 25 degree. So we are asked to look for our x, which is the only unknown we have in this shape. So how do you find your x? So what you are going to notice here is this angle here that is here is actually on a line that looks like this, whereby here is your 42. If here is your 42, you can notice this is actually a straight line from up here, and this angle here is just part of the straight line, and you have the rest angle here, which means the rest angle should be somewhere around here. And remember, we said angle on a straight line is equals to 180. Angle on a straight line is equals to 180, which means for you to get the remaining angle here, you just have to subtract this 120 from this 42 from 180, and you will have the angle that is left here. And how do you do that? Just say 180 minus 42, and that should give you 138, which means the angle you have here is 138 degree. The angle you have here is 138 degree. And also you can notice that this shape here that you have here forms a Z. You have it like this, like this, you have it like this, it forms a Z, whereby here is your X. And remember, what do we say? We said alternate angles gives you a Z shape, which means if here is X, here also will be X, and they are alternate to each other, which means what you have here also will be your X, will be your X. So if here is 25, here is 138, and here is your X, one thing you notice also is this is a triangle already. You have a triangle whereby here is 25, 138, and here is X. This is an angle. And there is one theorem about triangle also. We said all angles in a triangle are equals to 180. All angles in the triangle are equals to 180, which means if you add all the angles in the triangle together, your answer should be 180. That is, you have your 138 plus your 25 plus x to be 180, and 138 plus 25 gives you what? 163 plus x equals to 180. Your x equals to 180 minus 163, which is actually 17, which is actually 17, which means your x is 17 degree. Your x is 17 degree, and that's simply the answer. So this one earlier was just one way you can tackle the question, and here I'll be showing you another way you can also tackle the same question. In terms of plane shapes, it depends on how you can apply the theorems, and once you apply the right theorem to it, you will still derive at the same answer. So I'll be showing you another way you can still tackle the question, and you will see we'll have the same answer. You have two parallel lines like this. Let's just say I try to let's draw an imaginary parallel line to just pass through this center and be at the middle of the two parallel lines, whereby this imaginary line is still parallel to these two lines also. It is just in between them. And what you notice is this imaginary line you have here actually form a Z shape with this angle, which is 25 degree. It forms a Z shape with this, which is 25 degree. And remember, we said alternate angle as Z shape, which means if here is 25, here also will be 25. And coming up here also, you will notice that this line still form another Z shape with this one, and it is like this, whereby here is X and here also is still unknown. And if this small portion here, if this small portion here is 25 degree, that means we can actually get the remaining portion here, and the remaining portion there will be just be 42 minus 25 degree. 42 degree minus 25 degree, and your answer is 17 degree, which means the small portion up here is 17 degree. If the small portion up here is 17 degree, which means here is 17 degree, and we said they are alternate angle, it also means our x is 17 degree. That is another way you can still tackle the question. Can you see the theorem I use here is different from the theorem I used in the first solution, which means as long as you apply the right theorem and you applied it appropriately, we will still derive at the same answer. So thank you for watching this video from the beginning. If you're just seeing this video for the first time, please don't forget to on your notification bell, subscribe to this channel, and please don't forget to like this video also. If you have any question on theorems of plane shape or any other problems in mathematics, please you can drop them in the comment section below, and I will reply to every comment and every question you ask. Thank you very much. Have a wonderful day.